Hi everyone, today we're gonna create a customer support bot which is responsible for writing food orders of users in a real database and allow users to see what food they ordered. So we've got two requests we make to an actual database. This is quite an advanced LangGraph project which was requested, so please watch my introduction videos first before you tackle on that. I expect you to know at least the basics about state, edges, nodes and so on. You can learn that in this video. So what are we going to build? We are building this. A fake logged in user is able to create an order or see his orders. Everything else is blocked. We start by setting the user with a dummy token and give the bot an identity with a system message. Then we classify the intent. If it's off topic, we completely block it. If it's get all orders, then we make a query to the database, filter by the user and give him back his orders. If it's create order, we first want to validate the question. If information is missing, we provide the user a message of what's actually missing. If everything is alright, we rewrite the question to make sure that the time, like 9 PM, is rewritten to a valid timestamp. We then create an order that we put into the database and write a nice response to the user. So that's quite a lot, so we tackle that step by step. Okay, I'm in VS Code in the customer support IPython notebook. So this is the IPython notebook we will use. If you don't have the code, you can find the link to the code in the description. So since we work with a real database, our first step is to actually set up the database. You need Docker for that. So I've already set that up. Inside the Docker compose file, you can see we've got a Postgres database, actually pgvector. It's just an extension, but it works like a normal SQL database. So we run it on port 5433. Just run docker compose and then up. And now our Postgres database should be running. So we can see that with docker ps. Here our database is running. And now we can create our product and our user. So first we're going to load the OpenAI API key. And important, if you don't have installed it yet, install SQL Alchemy with pip install SQL Alchemy. So this is the ORM we use to create our tables and to filter the user and create our orders. So let's quickly go through that code. So first we create this base class with declarative base. We inherit from that, and with that we can create our tables and set the relations. So we've got this customers table, we've got an ID and also a name, and also the orders of the customer that has a relationship to the order table. And this is that table. And yeah, that's linked to each other. Then we've got this food item table because only food items available in that table are able to be ordered. So we provide some example food like pizza salami for that. And yeah, 3 tables, we set everything up. Here is our connection string. We set the engine. We create the tables with that command. And then we connect to the database with that session maker. So we create a new session. Then we create a new customer. We add the customer to the session, we commit it, and then we can see that we entered our first user. So the username is John. This is also the same name we will use in our fake token function. So we don't actually create a token because we would need an API for that. So we just use a dummy function to do that. Okay, so let's run the code and create our user. Here we can see our user John and also our items. Next step is to create our agent state. So this is relevant because we want to store multiple information when we pass the data from one node to another. So we store in that agent state the question, so the original question, the messages, so the system message, the human message, tool messages, and so on, the customer name, which comes from our fake function. So the username is only John in that case, tool calls, which make the request to the database. Order check, so we check here whether everything is complete in the request. So if the user forgets, for example, to pass his street, the LLM will tell him that this information is missing. Then the generation, which is the final output of the LLM, and the system message, which gives the bot an identity. So let's create that. And the first step, what we're gonna build here is, let me just remove that, the order check. So I first tried that with a structured output, but actually it did not work. I think it may be due to the combination of a chat prompt template, because in the examples I have not seen that, but actually I did not get the correct output from that LLM call. So what I want is I want the LLM to evaluate the input food items, which is a string, delivery address, and the order date. Only these 3 items should be evaluated. And if everything is there, like pizza salami, then we want to say yes, otherwise no. And here provided some examples that the LLM should have it easier to understand what I want. So let's create that prompt. We use this tuple version to create a chat prompt template. We pass a system message and also this template with the brackets. So this is only the question, which we pass here as dictionary. So that's the same key as here. And here we create our chain. So we've got our order prompt, passed that to the model and passed that to an output parser. So very simple. I think you should definitely know that if you watched the tutorial. So now let's run that. Let's invoke the check. And here we can see in this example, I want to order pizza salami. We can say, yeah, food items. We've got food items, pizza salami, delivery address is no, order date is no. Let's change that to fake street 123. And now we can see that the delivery address is yes, but the order date is still no. So this should normally be rejected because we need all the information for the database. Next step is the following, an inform prompt. So based on the order details provided, so these are the order details, you want to inform the user of any missing information. So based on that information, here you can see if delivery address is missing, the answer should be please provide the delivery address. So we don't want to return that to the user, but use that just internally in the agent. So if you pass that here, just a string, I think that's the easiest way to do it. The LLM is normally clever enough to work with that kind of information. Then we get your information is incomplete. Please provide the date and time for the order. So we provide that output from the first LLM call to the second LLM. So this is done step by step. Okay, then next function. So very simple. We just have this get name from token function. It will work with the state and we only return John. So this could be done a little bit more complicated, but I think for this example it's fine because it's anyway a quite complicated example. Next step is to create our tools. So we import the tool decorator from langchain core.tools from the tools module, and then we put that over this function create order, wants a customer name, food items, delivery address. So this is all checked, and also the order date. So the customer name comes from this fake function, everything else comes from the original LLM call. So here, this is the information that we require for that here for that function. Here we provide for the LLM a description of our tool with the arguments and so on, the expected output. And yeah, so we make a query to the customer database, filter by that. If we don't have that customer, we want to return that the customer was not found. And then we create an order with the custom ID, food item ID, the delivery address, and also the timestamp. We add that order and then we commit that to the session. Okay, then we execute it and return order placed. Here we can see this is just for the LLM that we see that everything worked. So we placed the order for that customer name, for that food items, to that address, and for that order date. The second function is a little bit easier. Get all items, so we just filter by the user. So we get the username here. If we don't get it, we will return that the username was not found. Then we will query by the custom ID and try to get all orders. If we don't have an order, we will return no orders found for the customer. Otherwise, we will just here provide that information in the list. So order ID with order ID, food item and everything and so on. So the price is everything that the user ordered. So that's what we're gonna use as tools for the LLM. By the way, if you don't know what tool calling is or function calling is, I have this introduction to tool calling. So if you don't know that, watch that video first. Okay, next step is to create a system message. And actually I experimented quite a bit to create a LCL chain, which we can use for creating our pipeline, but it's actually quite difficult to do that with variables. So I had to use the format function of the prompt to actually create a real system message because I was not able to use just a prompt template and use that as input to the model. So it doesn't work because you have to provide the complete list of messages to the LLM and it doesn't work with a template. So if you know how to do that, please tell me. I did not find it in the examples of LangChain. So let's create that system message And now we want to create a human message. So we always have to provide a list of messages. So this is the raw human message. I want to order pizza salami to Fake Street, and this is not a valid timestamp. So this is why we want to rewrite that. So this is what we're gonna do with that prompt template, and we provide that as system message. So here we provide identify and rewrite the time to match the correct format. So we want it in that timestamp format, which is suitable for the database. And we also provided the today timestamp. So if the user asks when did he make his order, he does not have to provide today is the, let's say, the 2nd of July or whatever. So important here, we say that we have got some examples how that is correctly formatted. So that's the user input and that is the desired format. So let's create that prompt template and now pass that prompt template to the LLM. We call that rewrite chain, and now we pass the question and also the current timestamp here. Okay, now again we have to provide this list of messages if we want to perform tool calling. I think that's not really well done by the LangChain team, but yeah, that's how it is. So we got the system message here with our user, where we provide the name John Doe as user input. And we also got this AI message. I want to order pizza to the Fake Street 123. So this was rewritten by the AI. Okay, now let's create our models with tools. So we use the chat OpenAI instance and use the bind tool method. And here we bind the create order tool and the get all orders tool. And that's, like I said, you have to provide this list of messages because we have to pass that to the invoke method. We can't use a template variable here. And we then append the result, so the message from the model, again to that list. And let's see how that looks like. So first, let's create this. And maybe let's inspect that first. So we've got these messages. And the last one, as you can see, we don't have a content here. So we got this tool calls ID, and we got the suggested tool, which we're gonna use. So the argument is John Doe for the name, pizza salami, delivery address, Fake Street 123, and the order date. The name of the function is create order. So this is done by tool or function calling, but we have to call that function ourselves. So we see that this is a list. So let's access the tool call attribute here. Here it is. So that's a list. We've got a name, we've got the arguments and so on and so on. So we can iterate over that tool calls attribute. And now we can use that little dictionary here to get the correct name and take that as input. So we get the function by this mapping, and then we invoke that tool which we selected, provide the arguments here for that function, and then we get the output. And now we have to create a special message called tool message where we pass in the output of the tool, and we also provide the tool call ID. So the initial question gets this ID, and the output or the tool call message here has to get the same ID. So the LLM has to know that this initial request belongs to that ID. Okay, so let's run that. And we can see customer John Doe was not found. So this is where we set the name to John Doe. And of course, I only created a user with the name John, not John Doe. So this is why we get John Doe not found, but that's for this example totally fine. So here you can see AI message is content. I'm sorry, but it seems like there was an issue with placing an order. It appears that your customer information was not found. I think that's a very valid response for the LLM. Later we will make a working solution where the username is just John and not John Doe. So now we created everything we need. So we created our LLMs with the custom system message, and now we can create real functions which work with the agent state to actually create our nodes. So the first one is the easiest step. So we just provide the customer name. Like I said, this is just a dummy function. We will always return John from this function, but normally you would provide a token when the user is logged in and then set the customer name for the agent. Next step is to create the system message. So first we're gonna extract now from the state the customer name. This is what we have to provide. So like before, we have to create our system message like that because we have to create a list of messages which we pass to the LLM. So we have to create the template like this. We use the format method, pass in the customer, which we extract from the state, and then we get our system message. And then we set the system message like this, but we also store the complete list of messages like here. So we get the system message and also a human message, which has as content the original question, which we always also extract from the state. So we're gonna use that function. And again, it's very important that you always return the complete state. Okay, next step is to identify the intent. So we get the question and pass that to the model with tools, and the model will identify if we've got tool calls or not. So this will be an empty list if we don't need tool calls, and otherwise this will be this complex object with arguments, the name, and also a tool call ID, which we store in the tool calls attribute of the state. Now we want to use the tool call state. So we extract that again in another function, which is called route attend. So we want to use that state to route to off topic or to the correct tool, which we then want to call. So if we don't have any tool calls, so if that's an empty list, we will return off topic. Otherwise, we will return the tool name, which is create order or get all orders. So we've got 3 different routes here. Then we also want a function to validate the order. So we will extract the question, run the order checker LLM, where we pass in the question here as input to the invoke method, and we store the output in the order check variable, and we again return the state. Next is that we perform the tool call. So this is the same logic like before, where I already explained it. So we extract the tool calls from this tool calls attribute from the state, we iterate over the tool calls, and then by this tool mapping, we invoke the tool with the correct arguments, which we stored also in the state, and then we append the tool messages to this first empty list. And very important that we extend now the state, so we extend the message state by these tool messages. So we always have the complete history in this messages attribute. Again, we return the full state. And then next function. So this is where we want to rewrite the initial question. So what we do here is we extract the question from the state. And then what we're going to do now, very important, we delete the first message and the second message. So this was the initial human message, and this was the response from the AI, where we had the ID of a tool which we should call, but we don't need that anymore because we will run that again to get an updated version with the updated question. So this is why we drop it in this case. So instead of 3 messages, now we've got a single one, the system message, and then we're gonna rewrite the initial question where we pass in the question and also the current timestamp. We will save the result in the questions attribute again, and we also append the output here to the messages array. So we've got a new and updated human message, which we store in the state. Okay, so we're gonna use that later and then make a tool call again. But yeah, we've already written that logic here above in this perform tool call function. So we're gonna run that again after rewriting the question. Okay, next step is to inform the user if anything is incomplete. So we just extract the order check from the state. So that's the order validation. We will use the missing info chain and pass in the information. So this will return then the output. So the output is always stored in the generation attribute of the state. And yeah, this will inform the user that something is missing. So let's also run that. And then a little bit more complex because we let the LLM generate this string, which looks like a dictionary. So yeah, I replaced the single quotation marks here with a double quotation mark and then used asked literal eval. Normally a function I would never suggest to use, but this was the only way I made it work. I guess with the JSON module, this might also work. But then I actually get the dictionary, so I can check in the items. If a value is no, then I can return incomplete. So this is a router again. Otherwise, I can return complete. So this is also used to create our final message. Okay, then we've got our off-topic response, and here we pass to the generation, I'm only allowed to tell your previous orders and allow you to create a new order. So that's what we gonna return. So we don't use an LLM to make that. We can just always return that string. Okay, now another step here for the final message, which we use an LLM for if everything worked and we want the user to be informed that an order was complete or that here are your orders which you made today or yesterday or whatever. So we extract the messages. So the complete history is stored in this messages attribute, which is a list. We pass that to the invoke method of the LLM, create an answer, and then pass the answer here to the generation attribute, and again return the complete state. So that's everything we need. So every function which we use in a node returns state and works with the state. Everything which is used for branching returns just a string, and this is then used in a mapping. So in this mapping, it looks like this. So we've got our router function, and here's the mapping. So if the return value is incomplete, then we will route to this node. If it's complete, then we will route to this node. So in the introduction of this series, I showed you what nodes are and what edges are, and this is how we're going to use it. So we've got an input key and a function which will be called when a node is run, and then we've got edges which are used for routing. We've got also conditional edges with a mapping, so incomplete routes to this, and so on and so on. So I will not explain everything, but I will just show you how this looks like when we compile it. So we have to compile the workflow at the end, set the entry point, which is update state with token. So we always extract the customer name first, then we will visualize it, and this looks like the same as in the introduction, which I showed you, because first we update the token, updated the customer name, generate the system message, identify intent, off topic, get all orders, create order. We validate the order if it's create order for complete and incomplete. Then if it's complete, we will rewrite the question, redo the intent, force a tool call, and generate the final message. So this is the workflow. I think not too easy, but also not too complicated. We don't have any recursion here. But yeah, let's actually test it. So first question is, how is the weather? So I will just extract the generation key. I'm going to show you how that looks like, because in this workflow, we always return the complete state. So in this case, we don't have any tool calls, no order check, and so on and so on. But I think it's easier to see if we only extract the generation key here. So I'm only allowed to tell you your previous orders and allow you to create a new order. So this works. That's the off-topic branch. And then I want to order 1 pizza salami today, 10 p.m. So we've got the pizza salami and 10 p.m., but the street is missing. So the LLM should be clever enough to evaluate that. Here you can see your information is incomplete. Please provide the delivery address. And then we do everything correct. We provide pizza salami, fake street 123, 10 p.m. Let's create an order now. Here the return value is your pizza salami to fake street 123 is being successfully placed in John. So the LLM also uses the correct username. Okay, last question after creating an order is to get the order. So what food did I order today? And now we branch into the get all orders function. And we can see, John, you ordered pizza salami today. So this is what we ordered just before. Great. So our use cases work. I hope you got an idea of how to interact with a real database and use LangGraph for quite some complicated branching and validation logic. As always, if you've got questions, please let me know that in the comments. Thank you very much for watching. See you. Bye bye.